Okay, this will be our introduction to chapter 6. It kind of follows from the last chapter, which was all the quadratic stuff. This one's going to be about polynomials. We'll just have like bigger exponents. We'll have like something x to the fourth plus something x cubed plus something. So this is kind of the beginning of that. Okay, this should mostly be a review of some things you guys saw in Algebra 1. Okay, but sometimes it just helps to see it again or think about it a different way. Okay, so there's a bunch of rules. There's like 4 or 5 rules. I'll give you a couple examples of each. And then you guys will have like a little activity to put it all together. Some problems. Okay, and the way I think is best, okay, is to not just try and memorize rules. Okay, it can be done and some people memorize them and that's fine, but if you can like think of a nice little example of each, you can kind of come up with the rule if you ever forget it. Okay, and I think that's good for any class. Like if you have a bunch of formulas and stuff, sometimes it's hard to memorize things. But if you can like understand what it's trying to do and why it works, then it's much easier to know like when to use it, how to use it. Okay, so these are like the first two. And see, most people remember sometimes you add exponents, sometimes you multiply exponents, and they're all kind of get mixed together. So if you ever get stuck, you can, like I said, just make up a little small example, and it can lead you to the correct thing to do. Okay, so with this first one, what we call the product rule, let me write a small example out and see if we can think about what the rule says. So if we had like x squared times x to the third or something. And again, most people remember we got to do something with those exponents, and many people remember the right thing, but if you ever forget, expand it out and see what happens. What does x to the second mean? X times x, right? What's x to the third mean? 3 of them, right? Okay, and this is just a big multiplication problem, isn't it? So how many x's do we have? 5. So what did we do to those exponents? Add them together. That's the rule. As long as the base is the same, in this case they were both x, you can just make the new exponent a plus b. Okay, 2 plus 3 gets you the 5. Okay, similar idea works for the divisions or quotient problems. Let's say it's like x to the fourth divided by x to the second. Okay, and let's say you forget what the little rule is here. Expand it out. X to the fourth is this. And x to the second is this. And then what happens when we start canceling? We had 2 up top that cancel the 2 on the bottom because remember anything divided by itself just kind of cancels out to be a 1. So we're just left with x squared. And what could we have done with the exponents? Subtract. Okay, this is a subtraction. X to the a minus b. Okay, so notice on the rule here, it's like it's x to the a times x to the b. The answer is still just x to some new power. We don't like multiply the bases together. It has to be the same base and it's going to stay the same base. The exponents just get added. Okay. Same thing with the division. The base is still just x. It just has a new exponent on it. Okay, so there's those. Now here's the other kind of common one, but it's a little different situation. Okay, and we call this one power to a power because you have some exponent to another exponent. Okay, there's like it's usually in parentheses. Okay, so you see 2 exponents on there. That's different than what we had before. We didn't have an exponent raised to an exponent again. Okay, so let's look at a little example and see what it is. If it was something like x squared to the third or something. Okay, first make sure we notice that that is different than what we did here, right? This one was x squared times x to the third. The new one is now x squared being raised to a power. It's a little bit different. We don't just add the exponents like we did before. Okay, and you can kind of come up with the rule again if you actually expand it out. Okay, x squared is x times x. Okay, and that thing's getting raised to the third power. So what does it mean to take something to the third power? Yeah, times it by itself that many times, right? So there's one of them. Here's a second one. Here's a third one. Okay, so I can just kind of expand it out. And then how many do we have? X to the sixth. So what do we do with those exponents? That's the 2 times 3. That's when you multiply exponents. So the rule is x to the a times b power. Okay, that's the only time you'll multiply exponents, if it's a power to another power. Okay, so any question on those? Those are kind of like the 3 basic ones, and there's like 2 or 3 like a little bit more involved, but there. Yes, sir. No, nope. Nope. This work here is just like if you forget the formula or you know something. I expect you to just multiply them and give me the answer. There's really no work to be shown. Unless I say like specifically expand it or something. Okay. Okay, so here's a couple of the other ones that might not be quite as familiar, and they're supposed to be a something like that. Okay, what if you have like some things being multiplied together and they're all in parentheses being raised to a power? Okay, so that's like a product getting raised to a power. Or on the right side, a quotient. What if you have a fraction in parentheses to a power? Okay, so let's put a small one up here. Okay, so how would we simplify that? Can we kind of expand it, write it times itself 3 times, if you want? Okay, this is kind of like the long way, so if you got the answer quicker, that's good, but let's say we forgot the rule or something, we expand it out, what ended up happening? Okay. Didn't we have like 2 to the third power? Which we know was 8, okay, but just to show the step. And then we had x to the third power. And then finally y to the third power. Okay, which again, of course, we would simplify if you know the value. If it's a number and you can expand it out, 2 to the third is going to be 8. So what really happened here? What would the rule be in the general case? Yeah, like everything gets taken to the power, right? So the rule could be like x is getting put to the a power, the y needs to then be put to the a power, and the z. So everything gets raised to that power. It's almost like distributing, where everything is getting sent to that power. You know, it's not the same as distributing because it's not like really multiplying, but it's kind of like that. Everything gets raised to the power. Okay, fractions are the same way. If it was like 2/3 to the third or something. Okay, again, kind of think of it like distributing. Take the numerator to the third power and the denominator. So 2 to the third over 3 to the third. And then you just simplify each and write it as a fraction. 8 over 27, that's it. Okay, so the rule, the numerator to the exponent and the denominator to the power. X to the a over y to the a. Okay, so let's just do one, just kind of special one. What if it's like something similar to the one we did, but what if it's like this? Okay. Okay, right, so the 2's not getting cubed though, right? Just the x and y are the thing. So the 2 can just be brought along, and then the x goes to the third, and the y goes to the third. So the parentheses kind of tell you like what the exponent's applying to. But the 2 was just on its own, so you could just leave it just like that. Okay, that'd be it. Nope, there's nothing else we can do on that one. 2x cubed, y cubed. Okay. Now, these other rules deal with, these are like the last two, okay? There's like, sometimes you have 0 as an exponent, and sometimes you can have a negative exponent. We need to know how to handle those. Okay, and anybody know if you take a number to the 0 power, or if you have a calculator handy? It actually is 1, isn't it? You might think it would be 0, but it's really not. If you take a number to the 0 power in your calculator, it's going to equal 1. Okay, and we'll talk about why in a second. There's a little pattern. So like if I took the number 3 to the 0 power, it's going to be 1. Okay, what about this? All right, those two cases are the case where you just got to go a little slow. Be careful. The second one, the middle one with the parentheses. Okay, that's telling you that the exponent applies to the whole number -2. It's -2 in parentheses being raised to the second. The rule says anything to the 0 is, okay. Yeah, so the difference, so the second one is saying that the exponent applies to the whole thing, -2. The bottom one now is different. Okay, and it's a little tricky. It's like saying this wants the opposite of whatever 2 to the 0 power is. So it's not -2 to the 0, it's the opposite of regular 2 to the 0. So this one's -1. It's the opposite of 1. Right? So just be careful. Yeah, so the second one, you're just taking some number to the 0 power. The number just happens to be a negative number. But the third one is saying the opposite of some number to the 0 power. So it's kind of like do the exponent first, then to, yeah, so it's a little iffy, but that's just the little details, and you know those always show up in the book and stuff. So now the good thing about this is, what if I gave you this? What? What's the rule say? Equals 1. Okay. Okay. Yeah. So if I put that on the test, where it's going to take you 2 seconds and you're going to tell me the answer is 1? Okay. I'm using the rule. That's just something to the 0 power, isn't it? It just happens to be a crazy thing, but it's something to the 0 power. Yeah, it's just there to show me that you know the rule. Okay. So, yeah, we'll get to all this stuff later in the year, right? The trig stuff. Oh, yeah. That's the trig. Okay, so that's that rule. Now, the last rule, okay, last one, and there's kind of a pattern that I want to show you so it makes a little more sense. If the exponent is negative, okay, there's a reason why this stuff works. And I'm going to show you a pattern with all those 5s and stuff. That's going to turn into like a pattern. Okay, so again, the positive ones we're familiar with. 5 to the first, anything to the first is just itself. Okay, 5 squared is 25. 5 to the third, so 5 times 5 times 5 is 125. Okay, we talked about something to the 0 is. Okay, so let's see if we can get this pattern here. So as the exponent gets bigger, as we're moving down this pattern here, aren't we multiplying by 5 each time? Times 5 again. Okay, so to work backwards, you're kind of dividing, aren't you? 125 divide by 5, you get 25. Divide by 5, you get 5. Divide by 5, that's kind of one of the reasons why you get a 1. 5 divided by 5. So follow the pattern. What's 1 divided by 5? Or isn't it just 1 divided by 5, 1/5? As a fraction? Okay, decimal point 2, sure. But the fractions will help you see the pattern. What if we divide that by 5 again? 1 over 25. And 1 over, we see a pattern? Again, your calculator will give you a decimal equivalent. It's fine, but to really understand it, I think the fractions are the way to go. Okay, so here's the deal with these. Okay, for whatever reason, having a negative exponent is not considered like simplified or not good. Okay, we want to be able to write things as either a positive exponent or as just like a positive, or as just a number, I should say. So what we do is if the exponent is negative like this, okay, like our 5 to the negative second. Okay, what you do is you can make it positive as long as you do the reciprocal of it. 1 over x to the positive a. So we always think reciprocals with negative exponents. Okay, so with our 5 example, let's just show the steps on why that worked. 5 to the negative second. Okay, again, we don't want a negative exponent. So to change the exponent from negative to positive, you just have to take the reciprocal of the number, and then you can make the exponent positive. That's how you get the 1 over 25. Okay, always reciprocal. So if we did like 3 to the negative third or something like that. Okay, we're going to see that negative exponent. We don't like that. We can make the exponent positive as long as you do the reciprocal. So the reciprocal of 3 is 1 over 3. That makes the exponent then become positive, and we can write that as a fraction as 1 over 27. Okay, that's 3 to the negative third power. Okay, so let's do a couple. What if you have a fraction already to a negative power? Okay, this is where it's real important to think about the reciprocal. If we take the reciprocal, we can make the exponent positive. So the reciprocal of that fraction is 4/3, and we can make the exponent positive. And now it becomes 16 over 9, 4 squared over 3 squared. There it is. Okay. So negative exponent, you think reciprocal. Okay, so now let's do one where we kind of combine some of the rules. Okay, and this will be like our last one, then I have some work for you. Okay, and let's do this one together. Let's go step by step. But this is kind of when everything gets put together. And we're just going to do a couple. Most of the time I'm just going to give you some smaller ones. But so jot that down. We'll kind of talk about it. Okay, so what would be something we could start with? You want to do the, yeah, like this exponent of 3 on the numerator? Okay, that's what I kind of noticed too. Like the numerator has something in parentheses all to the third power. So I can take each of these individual terms to the third power. That might be a good thing to start with. So x squared, if we take that to the third, becomes x to the sixth. Then there was a y, so that to the third is just y to the third. Okay, and even the negative, x to the negative third, raise that to the third makes it x to the negative ninth. Okay, so this is just one option. If you wanted to move the negatives earlier, you can. Okay, there's the numerator, and there's still some things to do, but let's look at the denominator now. Okay, I'm going to leave that x to the negative 2 just for a second. Can we do the same kind of thing in the other parenthesis in the bottom? It's, right, both of these things are getting to the second power. So x squared and y to the fourth. Okay, so I just did one, actually we did two things. One up top, one in the bottom. Okay, now there's some other options. Okay, you might notice some other things that you can do. No, there's still more. Okay, in the denominator, right? Can these be combined and these? We actually have some in the top and the bottom. Remember we had a rule, the very first one. You can add those exponents, right? So just kind of work on the numerator and the denominator like separately and simplify them. So the numerator will be what? X to the negative third, adding the exponents, and y to the third is still there for now. Okay. Now in the denominator down here, negative 2 plus 2, that's a 0. It's x to the 0. X to the 0 is just like having a 1 there. So it basically doesn't do anything. Okay, it's just like 1 times y to the 4th. It's just y to the 4th down there. Okay? You could put the 1, but you know, if you times something by 1, it doesn't do anything, right? All right, now here's a little trick. Okay? We have a negative exponent, don't we? Okay, negative exponent means reciprocal usually, right? When your problem's already set up like a fraction, a negative exponent just means that that thing needs to get moved. Okay, and the exponent will become positive. So if there's something negative in the numerator, you can just throw it in the bottom, make the exponent positive. That's just like doing the reciprocal. But make sure you change the exponent to positive now. Okay, right there. Now, if there was something negative in the bottom, you could do the same thing. You could throw it up top and make the exponent positive. That's just a little trick with moving negative exponents. Okay, so the x to the third is now positive on the bottom, and we just need to clean up. We have one last thing. We have y to the third over y to the fourth. We know how to reduce that. Where? We have x cubed here. There's an extra y on the bottom. If we start canceling everything with the y's, there's one more y on the bottom. Okay, because again, there was 3 y's on the top, 4 on the bottom, and we start canceling, there's one extra y on the bottom. So that's another little trick when you have these fractions, is ask, like, where are there more? Yeah, it needs to be a 1 up there. Okay, we can't put a 0 up here, right? Because it's really, like, you can think if you cancel everything out, remember, there's still like a 1 up there. So it's 1 over x cubed y. Okay, that's the final answer. You know you're done when you have no negative exponents and you have nothing else that can be like combined. Okay, so that thing has no negative exponents and it has no like terms to be combined, no like bases or anything like that.